Hello, this is Susan Poss. I'm a math instructor at Spartanburg Community College, and today I want to talk with you a little bit about dividing rational expressions or fractions. And if you remember from your arithmetic class, when you're dividing fractions, the first fraction remains in its present position, p over q. The second fraction flips to its reciprocal or multiplicative inverse, and so the r over s becomes s over r. And also notice that the operation changes from a division to a times operation. So I'm sure you probably remember seeing something like that in your arithmetic classes back in your past math history. And I'm noticing up here that you have to be careful about restrictions here. So anything that ends up in a denominator cannot be equal to 0 because division by 0 is undefined. So let's try a couple of examples. I'm going to start with this one. Again, you can see this is a division problem because of the notation there of the division operation. The first thing I want you to do as we start working here is factor everything that you can. So both numerator and denominator we're going to factor. And I'm going to do a couple of things all at the same time. I'm going to start factoring, and then I'm going to remember that I've got to get the reciprocal of this second fraction. So you'll see me changing this operation to a times operation and getting the reciprocal or the multiplicative inverse. So let me do, let me factor x cubed minus y cubed. Again, this one is kind of challenging. This is the difference of two cubes, and there's a distinct pattern which you may have to go to a different source to review. But you take the cube root of x cubed, keep the same connecting sign, the cube root of y cubed, and then go here and square, multiply the two together, reversing sign, and square the last term. X cubed, I'm just going to write it down. So let me change color so you can see what I'm doing out here. I'm going now to a times operation, and I'm flipping or going for the reciprocal of the second fraction. And all of that was already down here, but I wanted to talk my way through that. All right, so an important thing that I'm noticing here, I see an x factor here that will remove one of these x factors in the denominator. So that comes down from a x cubed to an x squared in that denominator. Remember, you cannot cancel this factor y with that y because that y is not a factor. It's connected by a subtraction operation. And here was the reason I wanted to work this problem. There's a specific, a little special something going on in here. Let me just pull that over here to the side. If you have an x minus y sitting over a y minus x, we talked in one of the earlier videos, you may not have seen that is in fact equal to -1. So I'm going to go ahead and cancel these two out, and I think I'll record the -1 up here. So those two things come out to be -1. And let me look around. I don't think I see anything else that can be divided out. So what do I have left? I have a -1 times this trinomial, which is, by the way, prime. When you factor a difference of cubes, that trinomial is always prime. Whoops, I'm about to forget this factor of y. Let me come back and squeeze that out in front there. And then I'm searching along the bottom, looking for what I have left standing there. I see an x squared. Okay, so you can type that negative or put that negative in the numerator, or sometimes you will see it written out in front of the whole fraction. Both of those forms are correct. Okay, so again, we factored, we did the canceling. Oh, and we had the reciprocal. Let's don't forget that. The factor, the reciprocal, we canceled out, and then we sort of put it all back together and made it look nice at the end. All right, so let's do one more that's a division example. think that's all we'll need. This one's pretty complicated on face value, but remember our first step is to factor. So if your factoring skills are good, we're in great shape. So just take it slowly. Numerator and denominator we're going to factor. So I'm looking at this trinomial. I can factor that into, let's see, 2 factors of 15 are 5 and 3 that will add to give me -8 and multiply to give me +15. All right, that looks good. On the bottom, I'm using trial and error. I'm sure you've been taught lots of different techniques for factoring. I want numbers that will multiply to give me 5 and add up here to give me 11 when I do an inside and an outside product. So I hope you see the positive 11x in there. Again, if you need to review factoring, I want to try checking a different section in the textbook. All right, so you noticed I did the change from multiplication into, from division into multiplication, and now I'm going for the reciprocal. So I'm going to factor this difference of 2 squares, and I'm going to put that result up in the numerator. So going for the reciprocal and doing the factoring at the same time. And now I'm going to work on this 2x squared minus 5x minus 3. I'm going to put that down in the denominator. So let me see. I need 2 numbers that will multiply to give me 3. And the products in here, let's see if that does it. There's a -6x on the outside. Whoops. Computer's smarter than I am. A -6x on the outside and a +1x on the inside. So that gives me this -5x I was looking for. Okay, so I'm ready now to come in and look for my common factors. Now remember, this is multiplication, so we're allowed to cancel out so long as these are connected by times. So I see an x minus 3 here. I see a 2x plus 1 there. And I think that's it. None of the others match. So let me go across. I'm going to pick up the x minus 5 times 1 times 1 times 2x minus 1. And then 1 times x plus 5 times 2x plus 1. So do you want to leave it in that form? I would leave it in this form. Remember, we said it's fairly common practice to leave the denominator in its factored form. If you want to go ahead and multiply out the numerator, you can do that, or you can just stop right there and leave it in factored form.